This video will serve as our source code for project 2. So let's open the workbench and we'll find our data sets here. Okay, so we have 10 LED data sets, and we have them named Riling assigned 2, and they have 2.4, 2.5, 2.6. So the 4, 5, 6, 7, 8, 9, 10 on is the various noise levels. So we have noise levels 4 through 13. So let's go ahead and open up noise level 4. And you can see here we have 1,000 instances. We have 25 attributes total, attribute 1 through 24. And we have our class variable. So that's our first data set, 4. Let's go to the Classify tab, pick out the Lazy Learner, IBK, the IBK algorithm. We see here we have parameters for this algorithm. We have the K and N variable. So right now it's set at 1. That's the default is to run IB1. If we change that to a 2, we will now be running IB2. Next we have down here, we have the nearest neighbor search algorithm. Here we're using a linear nearest neighbor search that employs a Euclidean distance, or basically the shortest path between 2 points. And then we have a window size here. So the window size sets the number of instances used in training the next, or classifying, I should say, not training, classifying the next instance. So right now we're setting that at 0, which means that we're basically going to use all of the instances of the trained to classify the next instance. So again, here's our algorithm here. K is 2 for IB2, window size is 0 for infinite. The neighbor search again is linear, and it uses Euclidean distance. Alright, we're going to split our training and test sets using cross-validation. 10 folds. Basically, our training, our data set will be split equally into 10 separate pieces, and we will use 9 of those pieces as training, and the 10th piece will be used for testing, and that will be repeated until all 10 pieces are used for testing. Those data sets are split evenly, and they're split according to a random seed. We can change the seed here, and basically that just tells the algorithm where we would like to start our split. This split is pseudo-random, so it's not a true random number. It's not going to go, it's not going to change. It's going to be the same number sequence each and every time. So, like I said, it's pseudo-random. So, let's go ahead and run this IB2 on noise level 4, and we get 70.6%. So now we're going to go up here, and we're going to change the K and N to 3, and basically that means we're going to run IB3 on the same noise level. And we get 74.3% accuracy on IB3. Okay, so let's go and get the next noise level 5. And this is already set to IB3, so we'll just leave that. And we get 71.3. We change that to a 2 for IB2. Run that again. We get 67.2 this time. That's again IB2. Let's open up noise level 6. IB2 on noise level 6 gives us 65.3, and IB3 on the same data set gives us 69.5. Open up, we're at 6. Let's open up noise level 7. Classify, run IB3 again first, this time 65.5. IB2 runs at 61.6. And open up noise level 8. Classify. IB2 is 58%. IB3 again is 62%. Noise level 9. And run IB3 on noise level 9, we get 59.4. And IB2 have to start it first. 55.1 IB2 on noise level 9. Open up the next noise level 10. And IB2 on noise level 10 is 52.3. Noise level, or IB3 on noise level 10 is 56%. Go get the next noise level 11. IB3 on noise level 11 is 53.4. And IB2 on noise level 11 is 50.3. Oh, wait. Open up the next one. Noise level 12. No doubt this will dip below 50%. And 44.9. And IB3 on noise level 11. Also below 50%. 48.6. And last we have noise level 13. IB3 on noise level 13 is 45.4. And IB2 is 43.2. Again on noise level 13. Noise level 13. We get 43.2. So, just take a quick look here. We have 70.6% to start out with a noise level of 4 on IB2, and 74.3% on IB3 on noise level 4. So, and we finished out 45.4. So, on IB3, and just to show you that is in fact IB3 on 13, and finished out at 43.2 IB2 on noise level 13. So, AHA in his study found that the IBK algorithms, IB2, IB3, did not handle noise well. And we have also shown that here, that these two algorithms do not handle noise well. Further justification on AHA's findings. And yes, as I said, this video also serves as my source code for Project 2 to show you, in fact, this is my own work. Thank you.